Hey guys, it's Michael Choi from Yorba Linda, California, and I'm going to be doing iCT lesson 10.1. And first, let's open up our string editor and string editor tester. Okay, a couple things I changed about this is I changed the single quotes into double quotes to make them strings, because I noticed that when you have a multiple words in the palindrome, when you just have character literals, then it erases the next words. So change those into double quotes in order to avoid that problem. And on top of that, replace is actually technically more or less for strings. So yeah. Okay. Oh shoot, I have the Pig Latin already written out. Sorry about that. So what we're gonna be doing is creating the Pig Latin thingy. So we're going to write public static string, returning the Pig Latin thing of string. And I've been getting a couple of suggestions on how to improve this. Just so you guys know, I'm following the pseudocode. Yeah, there we go. Sorry, I was having a word fart or something. I'm following the pseudocode directly, just so like Mr. Elliot can't say like, oh, you're copying it off of like someone, like if we have all similar clothes or something, because you know, you can't really say anything if he's the one who told us what to do, right? Anyways, let's move on. So input.trim. This will erase all of our excess spaces, and that's important. The way we're gonna determine where, like what words are in a string, is by determining where the space is. Okay, and we're going to also declare our result, and we're gonna return that as null. We're gonna set that equal to a null string, not just null. We're not just gonna declare it, because if we did, we would get a null reference exception, and that's a little hard to explain, so let's just skip that for now. Okay. So how we're gonna be doing this is we're going to split our input into words. Okay, the way we're gonna split our input into words is finding the spaces, like I said. So let's take the example. Michael is boss. Okay, in Pig Latin that would be Eichel me is ye ospe, right? So let's check if this phrase, in order to Pig Latinify something, we first have to only get single words, right? Single words with no spaces, right? So if input dot index of, and we have a space existing, is so when we check for the index of something, like we check for the character, right, of space. So we have two spaces right here and here, right? So it'll say, oh, the space is at like 5, 6, 7, or whatever, wherever the space is at, right? But if a space does not exist, like let's say we just had like Michael, that means it would return a value of -1, okay? So when it's equal to -1, meaning that, so if we said this, that means it's a single word, right? But we're not looking for single words. Let's say we're looking for spaces, right? So we would say greater than 0, meaning, oh, so a space does exist, right? Meaning that it's a phrase and it hasn't been chopped down into words yet. So we have to chop that into words, and the way we're going to do that is, okay, we're going to define what our first word is at the first space, and then after that we're going to be defining what the rest of the phrase is, and using recursion of Pig Latin to keep dividing this into more and more words from the phrase. So let me explain it after I just write this down. So we're going to say, actually let me delete that to make it a little bit clearer. Input dot substring of from 0 all the way to where our first space is, which will give us just Michael. Notice I'm not highlighting the space because we have to delete that space, since space defines where our words are, right? Okay, and then the rest of the hanging string is input. And just so you guys know, if you guys could do me a favor, could you change the variables for each of yours? Just because Mr. Elliot might get a little suspicious of, you know, if we're copying or whatever, or like if you guys do the same exact thing as me, then it's gonna look obviously like very suspicious. Anyways, the hanging string will be from the space or the first word all the way to the rest, right? All the way to the rest will be length. So right now, if you ran this once, it would say Michael, and then we would have this as is boss. Okay? Notice there's no space. It's not like this, right? This is very important. The reason why we delete spaces is because we need a stop recursion, okay? Our base case, okay? So now what we're gonna be saying is our let's see, our result. That's right. Our result. No, not return. Result is equal to the pig Latin of word. And the reason why we say this is because, okay, so let's say for example, okay, right now when we do this if statement, we know that it's a phrase, okay? It's not it hasn't been broken down to words yet, okay? Single word, and then what this when it's a single word, it's gonna mutate it, okay? Mutate into Latin, okay? So if we were to run pig Latin again with a single word, just Michael, right? Then it would actually mutate it into pig Latin or Eichelme, right? But let's just pretend our code works, and let's not code this for now until we finish this part. And then after that, what we have to do is we have to break apart this is boss part into more words, right? Because we can't just pig Latinify a I don't even know if that's a word, but anyways, we can't just pig Latinify a phrase, okay? Because a phrase consists of many words and we need single words, okay? And the way we're going to be doing that is hanging string. So pig Latin the hanging string. And to finish the rest, we have to say, okay, we have all of these into individual words after doing all this, and we're assuming that this part, when we pig Latin a word and there are no spaces involved, this works, okay? So the way we're going to make this work is we're going to say if a vowel exists in the first position, actually first, before we do any of this, let's create our helper methods, okay? And these will help us define how to approach these next parts. Sorry, my dad came in and yeah. Private static boolean is vowel. So this will receive a letter and check if it is a vowel, okay? There are more efficient ways to do this, but the pseudocode says check for A, B, C, D, then capital A, B, C, D, okay? Or A, E, I, O, U, and then the capital A, E, I, O, U, okay? So this is really simple. All we're going to be doing is saying if the letter is equal to A, result true, return true, okay? Else, if letter equals, remember double equals, E, return true. And then we do this all the way through A, E, I, O, U, capital A, E, I, O, U, and then else false, okay? Because if it doesn't match, if the letter doesn't match any of these A, E, I, O, U's, then obviously it's not a vowel, right? Okay, it says to use else if, but in all technicality, if it has a return statement, then that means it would automatically exit the function. So the reason why we use else if is so we can avoid like code repetition. Like if we just have if, we're assuming that it'll go through if, and then if it is this, then it'll do this code, and then it'll check all the rest, even though they're not the same, right? But what return does is it automatically exits the function, so technically we don't need this else. But in the but in the pseudocode it says we should, so I don't know. It's up to you whether you want to use else or if you just want to use, if you want to use else if, or if you just want to use else. So yeah, either way will work, but I will go with else if, even though you don't really need that else, because that's what he said in the pseudocode. Anyways, so if it's not any of these, return false. Okay, by the way, if you didn't understand what I was talking about with that else if and then versus the if, don't worry too much about it. I'm sure he won't dock off points or anything. Or, I'm not positively sure, but I'm pretty sure. Don't hold me accountable for that. So, let's create our next helper method. Okay, this is going to return the position of the vowel. Okay. Oh no, it's vowel position. The vowel position, and then it's going to return an integer. That's why we have the return type as integer. Okay, and then we're going to be inputting obviously the input or the string. And whenever we're using vowel position, we're generally going to be using this with single words. So actually, that's completely pointless to state that. But anyways, we're going to have to declare our test variable, our integer position, and the length of the input. Okay. Okay. We're gonna need another variable right here. That's integer start. Okay. The reason why we have integer start is because when we go through a word such as like chance, okay, we're going to be going through, okay, where do we start? We start at position 0, right? And then we're gonna check the rest. Okay, if we had started as like 3, we're gonna check from position 3, and we're gonna go through the rest. Okay, start is for checking like past a word, but it's more or less for the recursion itself, and you'll see why in a second. Okay, and when we declare our position, this position will default at -1. Okay, remember when we used index of and it searches for a character, right? And it returns the index value of a character. The vowel position will basically be the same thing as index of, but it's just a special case of index of, where it'll return the values of all vowels. You know, not just one character, right? And if you guys notice that when it does not find any of the given like character, then it'll default that as -1, and for the same reason, that's why we're going to default it at -1, right? So let's move on. If the start is less than length, meaning where we're starting at, like 0, right, is less than 5, okay, that's true, then keep going, okay? You'll see why, because when we use recursion on this, it's gonna like start the position at the second part, right? And then the third part, and the fourth part, and the fifth part. And the way we're gonna end this is, okay, at the sixth part, we finish the word, right? So it's great. The start is going to be greater than the length, so it's gonna just exit all of this and not do the recursion. Okay, hopefully you understood that. So next we're going to be declaring test char is equal to input dot char at start. So what we're going to be saying is the thing we're testing is at where we're starting. So 0, and if the start was at like 2, we would test the 8, right? So right now at our test char is C, okay? Okay, if, okay, is this test character a vowel? Where in computer terms we're gonna say is vowel test character, and if it is, then the position of wherever the vowel position is going to be at the start, because we know for sure that this is a start, right? And then it would exit this and return the position, right? Okay. But now let's assume, okay, the test character is not the test character we just tested is not a vowel, right? Like the beginning character, C is not a vowel, right? So what we're gonna be saying is the position. Right now we have to assume with recursion, a lot of things you have to assume in order to understand everything else, okay? And what I mean by this is actually a good example. So let's assume that vowel position works perfectly, right? It's like the index of, but it looks for the vowel and it tells us exactly, right? So we're gonna say the position is, well, if it's not the first, if it's not where we just started, it's the next one, okay? We're gonna check the next part of the string. So in chance, okay, it's not C, so let's find the vowel position wherever this part is, right? Okay, and the way we're gonna program that is say vowel position start +1, because we just tested start, right? So we have to check the next letter, and then we're going to be testing the same exact input, right? And when it checks the same exact input, so we have ants, right? Or hance. We have the same technically chance, but it's starting at hands. Okay, so H. The test character. Okay, it's not a vowel, so go to ants. Okay. Okay, well, A is a vowel, so the position is at start and return the position, okay? And if none of this works and it keeps going through everything and it says, okay, well, we already finished the entire word and there are no vowels at all, then it's just going to exit and pretend like this. It's going to say, okay, none of this exists, so return the position. And we defaulted that at -1, so it should work. Anyways, now that we have vowel position and is vowel, we can move on to mutate the word into Pig Latin, okay? The way we're going to be doing this is dividing it into 3 segments. And how we're going to be dividing that is saying, okay, if vowel is at first position, okay, and then if vowel exists, and, okay, let's say if no vowel, okay. And when there is no, when we check if the vowel is at first position and if the vowel exists at all, right? Automatically we know that this last, if we use else, it's the same thing as no vowel because it doesn't even exist in the first place, right? The second outrules that possibility. So this should be changed to else if, just to improve efficiency. And we're going to change the pseudocode in a bit, but let's first write what we're going to do, okay? If the vowel is at the first position, then all we're going to do is, okay, remember, these are single words, so we can mutate these, right? So, Michael, what are we, no, let's use is. Let's say the word we have right now is. What we're going to do is our input plus yay. So, is yay, right? And remember, we have to put is yay space, because remember, like the yay and a are at the end of every word, and then we have to put a space after because we remove the space, okay? This basically makes it so we're re-entering the space in after after deleting them in order to allow the recursion to work when we check for the spaces, right? And for if the vowel does exist, we have to say find the vowel position and then divide it into two segments, right? And then the way we're gonna, actually let's skip the pseudocode for now, let's just go into direct coding. So we're gonna split this into 2 segments. The place where the vowel, right before the vowel, and the rest of it. So like in again, let's say in chance, we're gonna say in Pig Latin it's antsche, right? Okay, the first vowel's right there. And then the beginning part is ch, and the rest is a and ce, right? And the way we write it, we say Pig Latin is ants, and then beginning ch, and then ay. So antsche. So hanging word, or actually let's rename this as begin equals input dot substring string from 0 all the way to where our vowel exists, okay? The way we're going to do vowel exists is vowel position of, okay, we know that a vowel exists, so that's why we're allowed to use the vowel position, or else it would return a -1 if it doesn't. The vowel position of input, and remember we have another thing called start, and because we're going to be checking from all the way from the beginning of the word all the way to the end, so we put that as start. String end of from the and the end will be from the end of the vowel position of the first vowel position all the way to string length, or the word length. And recall that substring does include the -1 or whatever, so we don't have to say -1. And our result will be this part, antsche, right? Ants, which is end, plus begin, plus ay. I don't know, I don't remember if I told you guys this yet, but please rename the variables. Just for like copying sake or whatever. If you guys are just copying this, or like, I know that people automatically just will, so like in order to like diversify these, please just rename the variables. And the last part will be input. So right here, no vowel exists, right? It'll just be input plus AY space, right? Because when no vowel exists in a word, we're just gonna, which actually technically wouldn't work, but with like language, but let's just say it does, we would just put AY, right? So let's work on these and we're gonna be done soon. Okay? If the vowel's at first position, so if input dot character at the first position is a vowel, right? And the way we check if it is a vowel, we're gonna say is vowel, right? Okay. Then do this one, okay? Okay, and the way we check if a vowel exists is the same way we check if a space exists, right? Remember how I said it was index of and vowel position are very similar. They just find the position of whatever character. It's just vowel position finds the position of a multitude of characters instead of just a single, right? So that's going to be in vowel, else if vowel position of input, and remember we have to have that 0 in the beginning to check from the entire word, is not equal to 0, not equal to -1. Because remember, if it goes through the whole thing and the position is -1, that means this does not exist. Actually, by the same way, you could do is greater than 0. Because remember, like how we said, like this thing. So it's basically the same idea as the space thing. So rewind if you need another explanation of that. We're gonna go through this. Anyways, this should be finished. Hopefully this compiles. Missing return statement. Oh, okay. So return result. Okay. Because once we finish modifying it, all we do is just return the result. That should be pretty self-explanatory. Okay, awesome. This works. If we pig Latin the word, it should get Eichelme is ye a ospe. Awesome, this works. Some further things you could do is like lowercase the if it's like a lowercase or something, make it to the front or something. But I'm not gonna explain that in the video because you don't need that. Because it didn't say in the pseudocode. Anyways, or like the direction. Anyways, that's all. And I'm really trying to finish this fast. So see you guys later. Thanks, guys.